Welcome students. In today's lecture we will study the successive differentiation, and we will start this lecture by the basic definition of differentiation. In the previous class we already have studied what we mean by differentiation, but we will still repeat the definition here. So suppose we are given a function y equal to f of x, given y is equal to f of x, then its derivative is defined as, then derivative of f of x is defined as, we have a notation like f dash of x for denoting the first derivative, which is also denoted by dy by dx for the function y, and this is defined as limit h tending to 0 f of x plus h minus f of x whole divided by h, provided this limit exists. Provided this limit exists. Then the value of this limit, so obtained by after evaluating it, is called the derivative of the function at that point x. In particular, we already know that the derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of log x is 1 by x, and so on. Here we are not going to take those details, but we are going to take the details of what we mean by the successive differentiation. So first we will define what we mean by successive differentiation. So this is a definition. Successive differentiation meaning, successive differentiation refers to repeatedly differentiating a function. Differentiating a function. Now, as we know that if we have a function, then we take its derivative one times, and we will denote it by f dash of x. Now, if we take the derivative of f dash of x, that will be called the second derivative of f of x. So it is like this. Suppose we are given a function y of x. So given y is equal to f of x. Then we define its first derivative as dy by dx. So the first derivative is, like, we will denote it by f1 of x, the first derivative, which is equal to dy by dx. And similarly, we can take a second derivative f2 of x, which is the derivative of f1 of x, and this will be actually d2y by dx2. And similarly, continuing like that, we can take the third derivative with respect to x for the function f of x, which we can define as the derivative of the second derivative. So it is d by dx of f2 of x. Now, as we know, f2 of x is equal to d2y by dx2, so this derivative of d2y by dx2, and now with this way it becomes d3y by dx, and so on. This is how we can take the derivative of the function successively and call this as the successive differentiation. Now here we take one example to find the higher order derivatives of a given function. So that we have a function y is equal to f of x, and suppose it is defined as x power 3 minus 4x power 2 plus 6x plus 8. Then our question is, find third derivative of f of x. Find its third derivative. Now how do we solve this problem again? So we will first take up, we have given y is equal to f of x, which has the value x cube minus 4x square plus 6x plus 8. Then we will first compute the first derivative. Then first derivative is like dy by dx, which we can also denote by f1 of x, or we can also denote it by f dash of x, and this is defined as d by dx of the function x cube minus 4x square plus 6x plus 8. Now this is equal to 3x square minus 8x plus 6. Therefore we can continue to find the second derivative. Now the second derivative is like f2 of x, which is the derivative of the first derivative, so this is equal to d by dx of f1 of x. So we can write this as d by dx of, now f1 of x is already known, it is equal to 3x square minus 8x plus 6. So therefore, now taking the derivative here, we get 6x minus 8. Hence the third derivative is denoted by f3 of x, now which we define as the derivative of the second derivative. So it is equal to derivative of f2 of x. Now we already have what we have, this f2 of x, so it is the derivative of 6x minus 8. Now the derivative of 6x minus 8, as we can compute, is equal to 6. So this is how we define the higher order derivatives. Now here in the successive differentiation, we have to take one nice theorem that defines as a rule for taking the derivative of the product of two functions. And this theorem is known as Lebnitz. Now how do we take up this Lebnitz theorem? This is if u of x and v of x are two functions, if these are two functions that are n times differentiable, that are n times differentiable, then the nth derivative of the product of u of x and v of x is given by, this is given by like this. So we have to take the nth derivative of u into v, which we can also denote by uv power n like this. So this notation here will denote the nth derivative of the product uv. This is now defined by the Lebnitz rule like this, summation k from 0 to n. So this n is the nth derivative here, depends on this n here. And here we have n choose k. Now u power k, that means the k derivative of u into the n minus k derivative of p. We have this notation nck. Now we already know that this is equal to n factorial divided by k factorial into n minus k factorial. And suppose this u power k denotes the k derivative of u, denotes the k derivative of u, and finally, and this v n minus k denotes the n minus kth derivative of p. So we have this Lebnitz theorem which will directly help us how to obtain the nth derivative of the product of two functions which are both n times differentiable. Now here we take first one example, and then we can also take the proof of this theorem. But in order to understand the example properly, the theorem properly, we will first take up an example and solve it using this Lebnitz theorem. So here our question will be find the fourth derivative of this function f of x, which is equal to suppose x power 5 into suppose sine 3x. So in our solution, so we choose according to Leibniz theorem, we choose u of x is equal to x power 5 as one of the two functions among these, and name the other function as v of x, which we now take as sine 3x. Now according to Leibniz rule, according to Leibniz theorem, we have the fourth formula for the fourth derivative. So we have this u into v, the fourth derivative of u into v, this is equal to summation k from 0 to 4. तो यहाँ पे हमें differentiation लेना है 0 से लेकर 4 तक, और n derivative अगर लेना होगा, we have to take the derivative, this summation as k from 0 to n. Now here in the Leibniz rule we have n choose k, तो यहाँ पे 4 derivative के लिए हम लिख सकते हैं 4 choose k. Now same u power k, that means the kth derivative of u and multiplied by n minus kth derivative of p. Now putting the value of k from 0 to 4, so first we put k equal to 0, हमें यहाँ पे मिलेगा 4 c 0. Now u power 0 derivative and v power 4th derivative. Then plus, now put k equal to 1, we get 4 c 1. Now here we will get u power 1, v power 4 minus 1. Or we can write here, this is like k from 0 to 4, 4 choose k, u power k, v power actually 4 minus k. It's not actually n is equal. Now here we will get 4 minus 1, so therefore this will be the third derivative of p. Then similarly 4 c2, u power 2, v power 4 minus 2 is again equal to 2. Then plus 4 c3, u power 3, v power 1. Then finally 4 c4, when we put k equal to 4, we get u power 4, v power 0. Now here this u power 0 will mean the 0 derivative of u, that means the u itself. And similarly the 0 derivative of v will mean the function v itself, that is sine 3x. But before calculating the derivatives, we first know that this 4c0 is equal to 1. So the first term is u 0, v 4. Then from the Pascal's triangle we can find out that this 4c1, or using the formula that is given in the theorem, we can calculate 4c1 is equal to 4 actually, and remaining we are left with u1 v3. तो इसी तरह से यहाँ पे नेक्स्ट ऑप्शन 4c2 वो 6 बन जाएगा, and here we will get u2 v2, then plus next 4c3, ये भी 4 आएगा, then u power 3 v power 1, and then finally 4c4, this will again be equal to 1, and we get here u4 v0. लेकिन यहाँ पे इस पूरे फॉर्मूला में हमें पूरी तरह से ख्याल रखना होगा, दिस u power 0 is not equal to 1, this actually the function u itself. अब यहाँ पे इस इक्वेशन में हमें क्या चाहिए, हमें u का 0 का डेरिवेटिव चाहिए, यानी u को यहाँ पे सब्स्टिट्यूट करना है इस टर्म में, u का फर्स्ट डेरिवेटिव, यहाँ पे u का सेकंड डेरिवेटिव, u का थर्ड डेरिवेटिव एंड u का फोर्थ डेरिवेटिव. तो अब हम ये चारों डेरिवेटिव्स u के कैलकुलेट करेंगे, एंड सिमिलरली यहाँ पे हमें v सब्स्टिट्यूट करना है, फिर v का फर्स्ट डेरिवेटिव, v का सेकंड डेरिवेटिव, v का थर्ड डेरिवेटिव एंड फोर्थ डेरिवेटिव ऑफ v. तो ये चार भी हम पहले कैलकुलेट करेंगे, एंड देन वी विल सब्स्टिट्यूट ऑल ऑफ देम इन दिस इक्वेशन दैट वी शैल कॉल एज इक्वेशन नंबर 1. ओके, सो नाउ जो u power 0 है, that means the 0 derivative of u, that is equal to u itself, and we have taken the value of u as x power 5, जो हमने ऊपर लिखा हुआ है, so u is equal to x power 5. So now the first derivative of u, that is u power 1, which is equal to derivative of u with respect to x. So therefore the derivative of u with respect to x हम इस तरह से लिख सकते हैं, derivative of x power 5, which is equal to 5x power 4. And similarly the second derivative of u, जिसको हम लिख सकते हैं इस तरह से, d by dx of 5x power 4, तो ये बन जाएगा 20x cube. And similarly u power, that is third derivative of u, that is the derivative of the second derivative, so this is the derivative of 20x cube, this will be equal to 60x. Then the fourth derivative of u, so this will be derivative of 60x, which we can take as 60. And similarly on here we will calculate this v power 0, which is the function v itself, and we have taken the function v as sin 3x. Then the first derivative of v, which is equal to derivative of sin 3x. Now as we know, derivative of sin is equal to cos, so is equal to cos 3x into derivative of 3x, which is equal to 3. And now the second derivative of v is derivative of 3 cos 3x. Now derivative of 3 cos 3x accordingly will be equal to minus 9 sin 3x. And now the third derivative of t, which is the derivative of minus 9 sin 3x. Now this will become minus 27 cos 3x. And finally the fourth derivative of t, which will be the derivative of minus 27 cos 3x. Now derivative of cos is minus 7 minus sine, so this will become 81 sine 3x. So we are done computing all the four derivatives of both u and v. Now we can substitute all of them in this equation number 1 to get the fourth derivative of u. So therefore from equation 1 we have this fourth derivative of uv. Now again we will repeat the formula here. This was equal to u0 v, sorry, it was u4, or let's look back here, it was u0 v4, so it is u0 v4 plus 4 times, now powers of u will keep increasing one by one and powers of v will keep decreasing one by one, so this is equal to u1 v3, then 6 u2 v2 plus 4 u3 v1 plus last is u4 v0. Now substituting the values, now u0 is equal to u, so and u is equal to x power 5. Now the fourth derivative of v, that's 81 sin 3x, 81 sin 3x, then plus now 4 times the first derivative of u, that we have already computed as 5x power 4. Now third derivative of v, that is here minus 27 cos 3x, so this is minus 27 cos 3x, then plus this term. First we have 6 here, then the second derivative of u that we have computed above, that is equal to 20x cube. Now multiplied by v2, that is the second derivative of v, that is computed above minus 9 sine 3x. Then plus now 4, the third derivative of u, which we have computed above as 60x. Now here we have to multiply with the first derivative of v, that's computed above to be equal to 3 cos 3x. So this is equal to 3 cos 3x. Then plus finally u4, the fourth derivative of u, that is 60, and multiplied by the function v power 3, the zero derivative of v, that is the function itself, that is sine 3x. So this is the fourth derivative of the product of u into v. Now we can simplify it by combining the terms with sine 3x and the terms with the cos 3x. So here we have the term with sine 3x, so this gives us 81 x power 5. Now combine it with this term, that is 9 into 6 into 20, so it is equal to 9 into 6 into 20, and we have also minus 9 here, so we can write minus here instead of plus, so this is minus x power 3. Then similarly this term, that is equal to plus 60 into sine 3, then plus the remaining terms which have cos with them, so it is 4 into 5 into minus 27, so we can say this is equal to minus 4 into 5 into 27 into x power 4, and plus this term with cos, so this is plus 4 into 3 into 6, and it has also x with it multiplied by cos 3x. So this is how we use the Lebnitz theorem to compute the nth derivative of any product of two functions. Now here we will put up one more example that you will try yourself. Example, find the fifth derivative of y is equal to x power 3 into e power 2x using Leibniz theorem. So therefore Leibniz theorem gives us a rule जहाँ पे हमें अगर प्रोडक्ट ऑफ टू फंक्शन जिस तरह से जहाँ पे इनका फिफ्थ डेरिवेटिव निकालना है, तो हम वन बाई वन एक्स पावर 3 के 5 डेरिवेटिव पहले कैलकुलेट करेंगे, फिर ई पावर 2x के 5 डेरिवेटिव कैलकुलेट करेंगे, और फिर लेबनिज़ थ्योरम से उनको कंबाइन करके हम फिफ्थ डेरिवेटिव ऑफ इस प्रोडक्ट को कंप्यूट कर सकते हैं.